Hello, Ritvik, is it audible? Ritvik, please respond. Ritvik, are you able to hear me? Tejasri,
Sir.
is it audible?
Yeah, yes, sir.
Yeah, okay. What is visible on your screen? Tejasri,
Yes, sir.
what is visible on your screen? What are you viewing? Hello.
Notepad editor, sir.
Notepad editor, okay. So in the previous session, we have ended with the base conversion functions, right? So we discussed about the need of the base conversion functions. So when we are dealing with non-decimal values, when we people are dealing with the non-decimal values, a non-decimal value in Python programming language can be represented in four ways. Either the non-decimal value can be represented directly in the decimal format, or binary format, or octal format, or hexadecimal format. So four kinds of representations are there. Four kinds of representations are supported by Python programming language. So by default, that means when you are assigning a non-decimal value either in hexadecimal format or binary format or decimal format or binary format, so whether you are representing it either in decimal or binary or octal or hexadecimal, at the time of displaying the value, at the time of displaying the value, displaying the content of that particular variable onto the output screen directly, it shows always in decimal format. What it shows? It shows the value in decimal format, decimal number system. It uses decimal number system for representing the number onto the user screen by default. So whether you are assigning the value in binary format or decimal format or octal format or hexadecimal format, at the time of displaying the content of variable directly onto the output screen, onto the user screen, it always displays in which particular number system, guys? It displays in decimal format. It uses decimal format. But if you observe the requirement, so I have assigned the value to the variable in the decimal format, but I need to display it in hexadecimal format, or I need to display the value in octal format, or I need to display it in binary format. So at that time, to handle the situation, we Python programmers or we Python developers are using base conversion functions. So to convert from one number system to another number system, at the time of displaying the value onto the user screen, we people are using these base conversion functions. Suppose you people are assigning a non-decimal value in decimal format to the variable. At the time of displaying the value onto the user screen, you need to display it in octal format. So for that, what we are doing, we are using print function. As part of print, we are using these base conversion functions. So these base conversion functions will accept what? Will accept only one value. So how many number of inputs are passed to these base conversion functions? So if you observe the number of inputs that which we are passing to these base conversion functions are only one. Only one value. How many values? Please respond.
One value.
Only one value.
Only one value is passed. So that input can be any kind of non-decimal value. That means a representation might be a decimal format or non-decimal format. Sorry, the decimal number. The format might be a decimal format or binary format or octal format or hexadecimal format. So to convert from one number system to another number system, we people are using this base conversion functions. For example, so I will give you example. So I'm having 25. Okay, so 25 is what? It is a decimal number. Okay, decimal number in the sense the number which it is a non-decimal value represented in decimal number system. Okay, so I want to show the content. I want to show this 25 in binary format. Means what? In terms of ones and zeros, I want to represent this particular number onto the user screen. So at that time we are using what? Binary. So bind function can be used. It's a base conversion function. So 25, what's the base of 25, guys? So what kind of representation it is? Hello, can anyone respond?
Sir. Decimal, sir.
Decimal format. Okay, so we are using decimal format here. So from decimal format, when I am using decimal format, what's the base of decimal number system? Base or radix value?
10.
10 is the radix value. So if you are not specifying here, by default it is treated as what? It is considered as decimal number system. So number is considered as a decimal number system number, decimal number system number. So it has to be converted into the binary format. So for doing that, so we are using binary. Bind function can be used. It's a base conversion function. By using that, we are converting this 25 into what? The binary format. We are converting into the binary format. For example, if I'm having a number like this, okay, so I am considering an octal number. So how you are representing octal number in Python programming, guys? So what are the first two digits? Sorry, what are the first two characters? First two characters for representing an octal number.
0 O.
0 O has to be used. That O character can be represented either in uppercase or lowercase. So you can represent either in uppercase or lowercase. No issues with that. So here I'm using 0 O followed by what? The number in octal number system. So I'm giving 123. Okay. So this is the octal number. So it has to be converted into which format, guys? When I'm using binary function, what happens here? This 123, which is represented in octal number system, it is converted into the binary format. Then which can be converted, guys? Hexadecimal. Even hexadecimal values can be converted into the binary representation. So what are the first two digits of the binary representation? Sorry, hexadecimal representation. First two characters. Hello, please respond. So I want to convert a hexadecimal value into the binary format. So in order to do that, what are the first two characters?
0
B.
0
X.
X. This X can be reprinted either in uppercase or lowercase. So here I'm writing 1, 2, 3 A B. Is it a valid value? Valid hexadecimal value? Hello? Valid one or not? Kiran Mai, please mute yourself. So is it a valid value, guys? 1, 2, 3 AB. Can I consider it as a decimal value or hexadecimal value?
Hexadecimal value.
Hexadecimal value. So how you are noticing it as an hexadecimal value? See here, the first two characters, 0x. So by seeing these first two characters, we are identifying it as a hexadecimal value. Then next function is what? Next base conversion function is what? Octal. So we are converting decimal number value into octal number value. So you can consider the same 25 here. So oct of 25. So what it does, 25, which is the representation of non-decimal value in decimal number system, is converted into octal format. Then oct of binary number can be given, right? So 0 B, 0 B, 0 small b or capital B can be used here. 0 B 1 0 2 0. Can I write like this? Is it a
No,
valid
sir.
one?
Invalid, sir.
Invalid. Reason?
Binary form has only 0 and 1s.
Superb. So it should not be given. 1 1 1. Is it a valid? Is it valid one?
Yes,
Please
sir.
respond. Now it is a valid one, right? So binary value converted into what? Octal format. Then the last representation. Which value can be converted? Please respond, guys.
Hexa.
Hexa. So what are the first two characters? 0,
0x.
0x.
X. Then 1, 2, 3, AB. Okay. So this is
Yes,
the
sir.
hexadecimal value. This is something about what? Octal. Now, what's the last base conversion function?
Hexa.
X. X. So to convert a decimal format into hexadecimal format, or to convert a binary format into hexadecimal format, or to convert octal format into a hexadecimal format, we can use hex function. Hex is what? It is a base conversion function using which we can convert a binary number into hexadecimal, or octal into hexadecimal, or a decimal into hexadecimal. So can I give examples? Please respond.
Yes, sir.
Give some examples. So what I can give here? So first thing is a decimal value, decimal format number can be given. So hex of 25 I'm giving. Next, which sort of values can be converted into hexadecimal values? Decimal to hexadecimal. Please respond, guys. Hello.
Binary.
Binary. So how we are representing binary value?
0B.
0b.
0 B 1 1 1 0. Okay. Then next,
Octa.
hex of. Tell me the first
0
two
O.
characters. 0
O.
O 0 O 1 2 3. Okay. So these are the examples for the base conversion functions. So for this, I will give one example. So we will discuss in the IDLE. So go to IDLE. Are you able to see the shell, Python shell?
Yes, sir.
So open the new file. Click upon new file. Are you seeing the untitled window?
Yes, sir.
Yes,
Now
sir.
I can write the logic. Okay. So I will convert. Control C. I'm copying into the untitled window. Okay. Bin of 25. So does it display the binary format onto the user screen?
No, sir.
Are you seeing the untitled window? Hello.
Yes, sir.
So to display it onto the user screen, which function has to be used?
Print.
Print function. So you enclose the whole function inside of the print such that the value will be displayed onto the output screen. Is it clear?
Yes, sir.
So enclose it in the print function. Are you following?
Yes, sir.
Yes, sir.
What I am doing, I'm displaying the value. Okay. So for displaying, we were using print function. So use print. Give some meaningful name. So what I am doing, I'm converting one format into another format by using base conversion functions, right? So give some meaningful name for the program. So go to file menu. So once you click upon file menu, it opens what? The list of options available within the file menu. Click upon save as. So it is asking for the path where the file has to be saved. So I'm saving within the Python folder, which is located in the desktop folder, which is available, which is available upon the desktop. So click upon desktop. So on desktop, here you can find the Python folder. Within Python CSCB folder, I'm saving the logic. Okay. So give some meaningful name. So base conversion, base conversion example 1.c. Save it. So after saving the logic, what's the next step? What is the next step? Run the program. So to execute the program, F5 functional key can be used, or else another navigation is what? You click upon run menu. So here you can find run module option. You click upon run module. See the output. Is it visible?
Yes, sir.
So these are converted into binary formats. Then the next three values are converted into which format, guys?
Octal.
Octal. Then the last three values are converted into which format? Hexadecimal values. So how you are identifying them as binary, how you are identifying it as octal, how you are identifying it as hexadecimal? See the first two characters. Okay. So if you see the first two characters as 0b, what does it indicate? It indicates a binary value. So if you see the first two characters as 0 and O, then what happens? It is considered as an octal value. So if you see the first two characters as 0x, it is considered as a hexadecimal value. Is it clear?
Yes, sir.
So when you get this kind of requirement, you people have to go for the concept of what? Base conversion functions. By using base conversion functions, what you people can do? You people can convert one format into another format. So decimal format can be converted into binary, decimal can be converted into hexadecimal, decimal can be converted into octal format. So based upon the customer requirement, you people have to go for the concept of what? Base conversion functions. So when your intention is to convert from one format to another format, we Python programmers are using this we Python programmers are using what? The base conversion functions. So the next fundamental data type which we are going to discuss right now is about float data type. So it's a fundamental data type. So what's the next data type, guys? So up to this extent, so we have covered regarding which particular data type, guys? Integer data type. Integer data type. So the next data type which we are going to discuss is about what? Float data type. Okay. So are you able to see the notepad?
Yes, sir.
Yeah, okay. So what's the next data type?
Float.
So with the help of this particular data type, what kind of data is handled by the program?
Decimal values.
To handle decimal values. To handle decimal values, can handle decimal values. Float data type is used. Float data type is used. Are we writing like this? Float space a equal to 10. Are we using this kind of syntax, guys? Please respond.
No, sir.
No, sir.
So where we are seeing, where we have seen this kind of syntax? In statically typed programming languages, like C programming language, we have seen this kind of syntax, isn't it?
Yes, sir.
Okay. So to handle decimal values, we people are using float data type, guys. So example, x equal to 10.5. X equal to 10.5. So it's a normal kind of representation, guys. So if you want to represent it in scientific notation, so we can use it. If we want to represent a decimal value in scientific notation, we want to represent a decimal value in scientific notation, that means in terms of e power. So in terms of e power, we can write it. Okay. So example for the scientific notation. Okay. So example for scientific notation. Okay. Example for scientific notation. So a equal to 1.2 e 3. This is called as scientific notation 1.2 E3. 1.2 E3 is called as what? It is called as the scientific notation. Scientific notation. Scientific notation. Is it clear, guys?
Yes, sir.
Then the next type of data type which we can see in fundamental data types is complex data type. What's the next data type? Complex
Data type.
data type. So to handle complex numbers, so this particular data type is supported in Python programming language, guys. So do we have complex data type in C programming language?
No, sir.
In Java? We don't have complex data type in Java. We don't have complex data type in C programming language. So it is supported in Python programming language, guys. So it is available in Python programming language to handle which kind of numbers? Respond.
Complex numbers.
To handle complex numbers. To know more about complex numbers, you can consult your maths faculty. Is it clear?
Yes, sir.
To handle complex numbers, so we Python programmers are using complex data type. Okay, so how complex data type look like? So a plus bj. This is the format. This is the format how complex number looks like. So in a plus bj, so a is called as real part. A is the real part, and B is called as, it is called as, guys? Anyone respond?
Imaginary part.
Super. So imaginary part. Okay. Then what about J square, guys? What's the value of J square?
-1.
-1. Superb, amma, superb. అందుకే మిమ్మల్ని ఐఐటీస్ అంటారమ్మా ఊరికడేనా. So I am writing so J power 2. So assume this one as what? Please respond, guys. Are you able to understand this notation?
Yes, sir.
So what I am saying?
J square.
J square. J square equal to what's the value?
-1.
-1.
-1.
Or A equal to what?
Under root -1.
So I can't use the symbol called as square root here. So because it's a notepad, right? That sort of symbols are not supported in square root of what? J. Okay. So assume this one as the square root. Okay, square root of J. Sorry, square root of what?
-1, sir.
Sorry, square root of -1. Okay. So this is about what? To handle complex values in Python programming language, guys. Okay. So assume I will give you an example. So example x equal to n plus 20j. X equal to n plus 20j. So what's the real part, guys?
10.
So this 10 plus 20j is called as a complex number or not?
Yes, sir.
It is a complex number, right? So what's the real part?
10.
Real part is 10. What's the complex part? Sorry, imaginary part?
20.
Imaginary part is 20. Okay. So if you got a requirement of displaying the real part onto the onto the output screen, or imaginary part onto the output screen. So to display it, so here we can use an attribute called as .real. So we have to specify what? Int. What's the variable name? 10 plus 20j is the value, right? What kind of value it is? It is a complex number. It is a complex value. So this complex value is assigned to the x variable. So what's the data type of x? Complex data type. So complex will be displayed, right? So I want to display the real part and imaginary part onto the user screen. So to display something onto the user screen, so which particular function is used by the programmer, guys? Print is the function, right? So within the print, you specify the name of the variable. So what's the name of the variable, guys?
X.
X is the name of the variable, followed by dot operator, and you specify the attribute as real. So real. Okay. So what it displays? What's the output of this
Real
statement?
part of X.
Real part of X. What's the value?
10.
10 will be shown. Then display the imaginary part. Okay. So specify the name of the variable. So name of the variable is what? X. X dot what?
Imaginary.
IMAG. IMAG. So IMAG is representing what? Imaginary part. Okay. So if you want to see the output, so you can copy this code into the ideally. Go to ideally. Open a new file. Are you able to see the notepad? Sorry, untitled window.
No, sir. Yes, sir.
So I'm copying this part. Okay. So deleting it, or else you can make it as the comment. Can I include these two statements as part of the code, guys? Please respond. Can I write this
No,
set of
sir.
syntax? Just for understanding sake, I have written like this. Okay. So you make it as a comment. Okay. I have made these two statements as comments. Okay. Save the logic. So it is an example for complex data type, right? So you save the logic. So within the Python folder, you have to save it. So in desktop, you can find a Python folder. Within Python CSCB folder, I have saved. Okay. So give some meaningful name. So complex example1.c. So I have saved the logic. So what's the next step?
So dot py.
.py, sir.
Sorry. Save as complex example1.py. Okay. Is it clear?
Yes,
Yes,
sir.
sir.
Now the next step.
Run the
Execution.
program.
So why it is not considering? Invalid syntax. Save the logic and go for execution. See the output, guys.
Yes, sir. 1020.
1020. So this 10.0 is the result of what?
Real part.
Real.
Real. 20.0 is what?
Imaginary.
Imaginary.
Imaginary part. So it's an example for handling complex values, guys. Complex numbers. Then the next fundamental data type. And one more thing, when we are dealing with the complex number, this particular point has to be remembered, guys. So real part of the complex number, real part of the. So are you able to see the notepad?
Yes, sir.
Yes, sir.
So real part of the complex number can be represented in binary format or octal format or hexadecimal format. But what about imaginary part? Imaginary part of the complex number. Imaginary part of the complex number can be represented only in which particular number system? Decimal number system. So this is the point you have to remember, guys. So decimal number system. Okay. Imaginary part of the complex number can be represented only in decimal number system. But what about real part of the complex number? Real part of the complex number can be represented either in decimal format or binary format or octal format or hexadecimal format. All the four formats are supported when we are speaking about the real part of the complex number. Is the point clear, guys? Important
Yes,
point.
sir.
Is it clear or not? So I will give you the examples. Okay. So real part. Okay. So x, here I'm taking a equal to, a is considered as a variable, guys. So here I'm taking 0b, 0b, 1010. So 1010 is representing what kind of value in decimal number system? 10. So it is representing 10, guys. So 0b, 1010 plus 1010 plus 20j. Is it a valid value?
Yes, sir.
So what I am doing, I am representing the real part in which format, guys?
Binary.
Binary format. It's a valid one. It's a valid statement. Valid. Then a equal to, let us suppose if I am writing like this, 0, 0, 1, 2, 3 plus 20. Is it a valid one? Please respond.
Yes,
Valid or
sir.
invalid?
Valid, sir.
So what I have done, the real part of the complex number is represented in
Octa.
octal format. Then a equal to, let us suppose if I am writing like this, 0x 1 2 3 ab. Is it a valid one?
Yes, sir.
It is also valid, but you consider the examples for invalid one. So b equal to 12 plus 0b 1010 j. Valid or invalid?
Invalid, sir.
Invalid, sir.
Invalid. Reason is what? We cannot represent the imaginary part of the complex number in other formats except what? Decimal number system.
Decimal.
So except decimal number system, we can't use other kind of number representations, guys. So we can't go for binary or octal or hexadecimal for representing the complex, sorry, for representing an imaginary part of the complex number. So it is invalid. Can you give any other example, guys? B equal to 12 plus 0, 0, 1, 2, 3. 1, 2, 3. Valid or invalid?
Invalid.
Invalid. Please remember this point, guys. Invalid. Then b equal to, so 12 plus 0 x 1 2 3 ab. Valid or invalid?
Invalid.
Invalid. Reason? So if you observe the reason, so what I have done, imaginary part of this complex number is represented in which particular type of number system, guys? In hexadecimal.
Hexadecimal.
So making it as invalid. So is the point clear?
Yes, sir.
Next data type is, so before going to the next data type, so what sort of operations we can perform upon the complex numbers? So if you observe the type of operations which we can perform upon the complex numbers, so addition operation is supported, subtraction is supported, multiplication is supported, division is supported. Is it clear, guys?
Yes, sir.
Yes, sir.
So what sort of operations are supported upon the complex numbers? So these are the operations which we can perform upon the complex numbers. So operations which we can perform upon complex numbers. So point to be noted, guys. So what sort of operations we can perform upon the complex numbers means addition operation can be performed, subtraction operation can be performed, multiplication operation can be performed, division operation can be performed. So the next data type which we can discuss is about Boolean data type. The next data type?
Boolean.
Boolean data type. So Boolean data type. Boolean data type. So under Boolean data type. So what sort of values are accepted, guys?
True or false?
True or false. So these are the values, guys. Please remember the first character of the Boolean value is represented in uppercase and remaining characters are represented in lowercase. Is it clear? So
Yes,
we already
sir.
discussed regarding this particular point, guys. So true True is a value, false is a value. So it is one of the keyword of the Python programming language, guys. So true, false, none are the keywords, right? So true is a Boolean value, false is a Boolean value. So these values, true and false, they are considered as what? Reserved words of the Python programming language. Do you remember that point? Hello.
Yes, sir.
So true and false. Please remember, guys. For example, if I'm writing x equal to true, is it a valid one? So
No,
what's the
sir.
data type of x?
String.
String. No, it won't be considered as the string. So when I write this kind of statement as part of the logic, it leads to an error. Leads to an error. Is it clear, guys? So we don't have character data type, we are having strings. So how we are representing string values in Python programming language? Either in single quotes or double quotes or triple quotes, we are representing the string values. So this kind of statements, when we are including in the program, means it leads to an error. Okay, so it is what? An invalid statement, guys. Invalid. So true is what? It's a Boolean value. It has to be assigned to a variable, means at the time of assigning the variable. So this particular true value has to be represented in which case, guys? The first character, init capital representation has to be followed. Means what? The first character is represented in
Upper.
uppercase.
Uppercase.
The remaining letters are represented in
Lowercase.
so this is the valid syntax. Okay, so valid one. Next, I'm taking y equal to false. You tell me, valid or invalid?
Invalid. Sir.
Invalid, sir.
Reason?
F must be in
First letter
capital
of-
letters.
Superb. So f equal to false. So this is the valid one. Is it clear? Hello?
Yes.
Is it clear or not?
Yes, sir.
So we will see one example regarding Boolean data type, guys. So go to the IDE. So open the IDE. I'm opening a new file in Python IDE, guys. So are you able to see the untitled window?
Yes, sir.
Yes, sir.
So here I'm writing x equal to true. Is it a valid statement or invalid statement? Please respond.
Valid statement.
Valid statement. Z equal to false. Valid or invalid?
Valid, sir.
Valid. Now I will write print of x plus y. Then print of, sorry, not printf, it is print of x plus z. X plus z. Next, print of x into y. Next, print of, sorry, not printf, print of x into z. Can anyone tell me the output of this particular program, guys? So when I'm assigning true to the x variable, internally true is considered as 1, false is considered as 0. So based upon that assumption, can you tell me the output of this particular program, guys? So what's the result of this statement? Print of x plus y.
True.
Huh? What will be the output? So true is considered as 1, false is considered as 0. So internally true is considered as 1, false is considered as 0. So based upon that assumption, can you tell me the output? So true plus true, x is true, y is true. So true plus true is what? What's the result?
2.
2.
No, it is not 2.
1.
1 plus 1 will become 2. So I will show you the output, guys. So it's an example for Boolean data type, right? So save the program. So I'm saving within the Python folder, guys. Saving within the Python folder. So within Python CSCB folder, I'm saving the logic. So it's an example for Boolean data type. Boolean example 1 dot Python. Okay. Save it, then go for execution. And the program. So what are you viewing here? See here. Are you able to see the output window?
Yes, sir.
So what it is showing? What's the result of first print statement?